I have a love-hate relationship with the slippery slope of count and for each meta arguments. They're fundamental building blocks of any Terraform code, it seems, but just as you really begin to understand their power, you can slip into some truly complicated patterns regarding their use. I'm Olaf, and this is Jason. We're covering some essentials of a count and for each today to help you in those times when these simple arguments can get quite complicated. If you think about the basics, it can help with maintaining clarity later.
I remember when I could get away with just using count. It was simpler times.
Yeah, those were simpler times. Let's start there actually and build an example to show how exactly that works. I'm going to use the null provider because it's just a whole lot quicker to work through this example. But this works with any resource, obviously, and for modules for that matter. So to start off, we're just going to create a null resource. And let me make that a little larger so everybody can see that better. There we go. Let's see, and I got to name that one. So I'm going to give it my classic this as a as my unique name. And then to this null resource, so there's not really a whole lot that this provides us. So I'm going to add, I'm going to type that. I'm going to add a trigger. And let's see, I'm going to create a name value. So the triggers are basically just arbitrary values on a null resource, and they can, I guess, provide a lot of different types of value, but in this case, we're just using it to add some meta stuff. So I'm gonna go ahead and name this one. And let's see, because we're talking about count and for each, I'm gonna start with count. So we'll just kick this off with a count. And we'll start real easy. I'm just going to start with 1. And let's see how that works. All right. So as we can see, I apply with count 1. We can see that it's going to create 1 object. And when I say yes, it in fact goes and creates that. Now, if I consider count as a Boolean, then I can also set count to 0. And you might expect that that wouldn't do anything, that it just wouldn't make any changes. But in fact, what Terraform is going to do is destroy that object, because now specifically the count is 0. And so you can see here, I've got 1 item to destroy. So this can be handy as a Boolean, but it is also handy as a multiplier. And that's really the way that I think about it. All right, so if we apply that, we can see now that I've got 2 items coming in. There we go.
I just have to mess with you a little bit. But what happens if you use a negative number?
Yeah, okay, so it is a multiplier. So if I were to use a negative number, it is a little like, what would that do? So if we try that out, let's see what it does. So right here, we get a nice little error by Terraform saying that that is an unsuitable number. And I can tell you from experience that it also doesn't work if I put in a decimal point. So the only numbers that work are what would be referred to as natural numbers. So this was going to be a, let's see, it's a multiplier of a natural number. So that's going to be all positive and all integers as a true multiplier. All right, so let's see, we're going to add an output so that we can kind of see how this is looking actually. So I'm going to output my things, and I have 2 of them. So then we're going to just put a value out here. And in this case, I'm just going to clean it up a little bit, and I'm going to just output the I'm going to output the metadata that we've established here with the triggers. So I'll just keep it tight, and we'll apply that. All right, so we can see here that I have 2 objects. They have the same names, and yeah, I can see exactly how it relates to when I create 2 of them, that I can see both of those things. The meta is the same for both of those things. Okay, so we have our count being used. We can see that it's creating 2 items, but I want to add the count object and its associated index parameter to that, or property. So I can change the name here to expose that. So I'm going to just go ahead and add count.index. And now we're going to change the name per item to make things a little bit more dynamic. And so we can see here we've got 0 and 1 listed as our 2 things.
Weren't they actually named thing 1 and thing 2?
Yeah. We can do that. Okay, so let's do it this way then. We will, instead of doing the count.index only, I'm also going to add some math to that and just add 1, because count is 0 based, and although we count 0 as 1, it is going to start with 0. So I'm going to add 1 to the values and then apply that. And there we go. Now we've got thing 1 and thing 2. Good call.
Can you show us the state, what it actually looks like now?
Yeah, that's probably a good thing to look at. So we're going to just list it plainly. And so we can see, even though I changed, I'm using count.index plus 1, that's only really put into the meta, and then therefore shows up in the output. The objects themselves, so, are still 0 based. And when we look at state, we can see that there is this 0 and this 1, and these are indices because it's a collection, and it's just a list type, or it may actually be a set. So let's look at something in a little bit more detail. I'm going to show the object itself. We'll just pick 1 here. And there you can see, so I've got all the details that exist within that. And also it's worth demonstrating that I can call that item by specifying its index value within the collection. That'll be very important later. So it's also important to realize that even though it's one resource in the code, the count creates like independent resources. So the resource object is a collection, but each item within that collection are individuals. So right now we're at 3, and if I want to add 1, then we are now going to, apply. So we're now just going to add 1 right onto the end, and so we have thing 3. Now it's important to realize that what didn't happen is we didn't recreate the entire collection. We created 1 resource at the end of the list. And so you can see that it says 1 added, and that's important. So on the other hand, if I go in and I want to just manually remove one of those items, let's say something if you're applying this to like a cloud provider, and one of those things gets removed from the cloud, you might assume that it's going to remove, that you're going to have to recreate all of them, because when it goes to reconcile that, it's missing one of the objects, and so it has to recreate this resource. But they're independent, so if I remove a single one and then I apply this again, you'll see that I'm still only adding 1 to the list. And actually, before we do that, I'll just show the list. So we can see that I have 0 and 2. It didn't fall back to 1. And then when I apply this to add, then it's going to create 1. So we didn't get a third item, a number 3 in the index added. It goes and replaces the one that was missing in the middle. So it handles each of them independently, and that's actually really helpful and really important to realize. One more thing about count that's interesting. Count accepts numeric expressions, but it has to be known before any resource actions are taken. So right now we're using like a static value that obviously is a literal value, and so it is known. But if I were to point to something that maybe is it's a resource property that hasn't been created yet, then Terraform's not going to know how to apply that. So Terraform has to know how many resources it's going to create before it can move on to the apply phase. Okay, and let me go ahead and apply that to get us back to 2. So we've gone through that a bit. Let's get into the meta arguments now. Yeah. Apply. Yep. Okay. Sometimes, oftentimes, in fact, you'll find yourself in a situation where you need more than a count object. Remember how in resources that use count, we get a count object with the index property? That's good enough where all we need to do is iterate on a number, but in most cases, you're going to want to do a little bit more than that. So let's add some more data. Let me grab this over here. We're going to add some more data to exercise more values within our properties, our objects. Okay, so I've got a little bit of a data set here that we're going to use. And now, because of the way I've named the keys in our local map, and you can see I've got thing 1 and thing 2 as key names here, then it's a little bit of a cheat. I could use count to walk this map. And let's actually go ahead and try that out and see what it looks like. So I'm going to change out this object because now I'm going to point to the local map. And so this is going to be local things. And I need to point to one of those keys. So I'm going to then use the count value. And I have to, again, add the math to it because it's 0-based. And I named them thing 1, thing 2 per Jason's call. And then I want to grab the name property from that map. So if we apply it like this, and it should. Oh, I put my brace in the wrong place. Yeah, there we go. It's a property. Okay, so if we apply it like this with a corrected name, then I should be able to get my values right out of the property map. And I do. So I'm replacing then the names from the values that come out of the property map. And that works okay.
That looks like it's going to be a mess. You created a dependency on both the key and the value names.
Yeah, that's fair. So I have a hard-coded key name here, and then of course I'm pulling the property name here, and then as we increment that and point to all the other values, then this will be probably a little confusing to read as future self goes back and reviews the code. So instead, let's try out for each and see if this will make this look a little better. So we're going to do for each, and this will be for each of the local things. Then I want my name value to become, so just as count gave us an object and property, for each is going to give us a object called each, and each is going to have properties of value and key based on what the value of for each is. So for each takes either a map or a set only. You can't use a list. If you use a list, you have to set it to, you have to do a two-set function on it. And so by doing that, you then have either an index-based approach, a numeric index-based approach, or you have a map that has key and values. If it's a set, then your value is really the only thing that's valid, but key would equal to the same thing as value. And if it's a map, then key value obviously relate to the map properties or the objects. So I'm going to try using each on this. So I'm just going to add each of the properties that come out of the map in this case. So we're going to say each.value.name, and then address is going to be each.value.address. Clothing. And this just down the line. So you can imagine if I have a lot of different values, and maybe I don't even want to use them all, maybe I only want to pull out certain ones, then these are the options available to you, so you can explicitly call all the things that you want to add. Okay, so we're adding all of those values, but right now our output is just the name. So just to be a little clearer, I'm going to grab more output here. And let's see if we can get the value that we want out of this. Apply that. All right, there we go. And so as an output, we can now see all of the values reported from the resource objects that are created. And you might say to yourself, this just looks like you outputted the map, and it certainly does look like that. But if I, again, look at the state list, we can see that I have the 2 objects. And if I do a show, then we can see that I've got all of the components of those objects within the state. So we'll come back to that perhaps later, but for now I want to talk a little bit about the outputs. So as you can see, I did a little bit of work here on a forced for loop on this, and I just want to draw a little bit of attention to that without going too deep into it. But basically, I'm walking the map for this output. The output basically takes, it is a map, so I'm going to set values for key and value. So I'm using K and V in this case, and then I specify the name of the collection above, and so that's this null resource dot this, and then I'm going to set my key here to whatever the key is from this collection, and then I want a map of all the values that comes after that.
Can you show us what the state looks like now for those 2 items?
Yeah, so we touched on it briefly, but if we actually want to use those objects, so I'll go back to the state list. So we can see the 2 items, and whereas before I had these were index based, these were 0 and 1. Now that they are map collections, then they actually have keys associated with them. So to get to one of these, then I can jump in tighter. And so I want to do a show, let's see, show null resource this, and then I need to call one of those. And I am in PowerShell, so I'm having to do a little bit more work to, let's see, that's not right. I have to do a little bit more work to access the value, because it's nested within what is it, Go code, I think, and the way that PowerShell passes all of this into the executable, yeah, it's just a little bit different, a little bit unique. So your mileage may vary on this particular piece. There. Oh, yeah, I got
Escape characters.
Yeah, exactly. There's something wrong with my history too. All right, let's try that again. There we go. And I do have to have the number in there. Right, thing 1. Yeah, that looks right.
Why is it being? I think you forgot the dot this.
I have two ticks in there.
Don't you need the dot this?
And I do need a dot this as well. There's all kinds of problems in that.
There we go.
Okay, so with the name set correctly for interpretation within your shell, then I can access just an item within the collection from the state, and I can report all of its values. And if I were actually calling this out as an object within using HCL within the Terraform code, then I don't have to have the escape characters that you see me using at the command line in this case. So again, that's just your command line interpreter and how that works with you. Since we've done that to show the state value, let's actually just drop that into the output as an example. So I'm going to output, and I'll just output one of them here. This will be, let's see, this will be the null resource, this. And again, no escape characters needed here. And I'm just going to grab all of the triggers. And we'll apply that. Okay, and so we can see this second output here shows distinctly the one item. So my ability to call that one item works just as you might expect it to. And again, I have to use the key name in this case. The index is no longer available to me because it is based on the for each is bringing in a map instead of a set. Okay, so one other thing that I want to show you about this, we're going to give it a little bit more detail, a little bit more material to work with to really show you the power of for each. So I'm going to add another map. Let's see. So let's add some address information. Right now we can see that the address is just generically the box, but let's add a little bit more detail to that. So I'm going to get rid of the second output and so right now I've added address information and I want to add that second map into my for loop. Okay, and that's going to take a little bit more work. So I am going to change this for each code. Okay, so just stepping through this briefly before we execute this. In this example, I've got a for each, and then I'm using a for loop to step through the map, and I'm actually using a nested for loop to walk through it. So a lot more material going on with the for each object. But in this case, it's because what I want to do is I want to combine two maps and grab values from both of them in my output. So I'm first going to set values for my key and value. So just like before I used K and V, here I'm using something a little bit more explicit just to keep things separate. So I'll have a key named thing and a value named characteristics. And that'll come out of local things. And then if we scroll a little bit, we can see that I am then going to use thing, the key, as the key for my collection. And that's important. And then inside of that, I'm going to create a set from however many items are within that. And within that, I can now step through another map. And in this case, the map is going to be local.addressBook. I create new key values on address and information. And then I step right into assigning the map with all of the material that I want to add. And explicitly, I have really the only thing I've changed is the address item by pointing to information, which is one of our values from above, and its property name of location. And that maps to up here in address book, you can see that it maps to the location property. Okay, and so in doing so, I pointed out that it actually drops this into a set. The set only has one item, so you can see that, and this is very typical actually, the way that I had to build that nested for loop, I wind up having a single index value always underneath it. So I just hard code in that 0 because it's the only one that will ever exist there. And so that's the difference I have to make for the name assignment. But other than that, you can see that the for loop for the output still exists as it was. So all of that still reads the same. And we will apply that. Lots of changes. Okay, and so you can see right away that given the new code for the nested for loop, I've now replaced the address with the actual address instead of being simply the box.
With count before, you said Terraform had to know the count before any apply steps were taken. How does it work for each?
Yeah. So, and I did say that this would be important before. So we're pointing to the key of the collection from before, and why that's important is because just like count, count needs to know the number, the value of that quantity before it can do an apply. This is the same way. So I create a number based on this this set. So if I go back and look at my map, there are let's see, in this one it was thing, right? So I'm pulling the key off of local.things, and key of local.things is thing 1 and thing 2. So we know that that's 2 items. So just like in count, really what's happening here is for each is getting a number equal to 2. And then there's a bunch of other stuff happening that's providing values that feed into the each object, each dot key, each dot value. But first and foremost, I have to have a number just behind this equals sign. And that number is equal to whatever this key assignment is right here. If it were a set, then it would be the length of the set that you're pointing to in that case. But always a number, just like count in that fact. I think one of the most important takeaways for count and for each is that they are working to achieve the same thing. So we're talking about the what for each actually looks like, and it has to equal a number. The object of both of these meta arguments is to produce that number that Terraform can use to produce an accurate count of resources for the graph. For each can get way more complicated, obviously, and add some much needed value. But if you always consider that it has to produce a number first, then it'll make using it a little easier. There are also scenarios where I combine count and for each in one module. You can't use both count and for each in the same resource or module, but you can create, say, a VPC with count, and then use for each in a subnet resource pointing to the VPC collection to create a subnet in each VPC. This establishes a chain so that you can focus on your top level resource and have it automatically cascade to dependent resources with the correctly named resource.
I think it's worth noting that you've done a lot more research about Dr. Seuss's Thing 1 and Thing 2 than I ever thought possible. Also, there's a lot of value you can get out of for each, like in your nested for loop example. You can make it as complicated as you want, but it's worth mentioning that adjusting your input sources can be the simplest way to achieve the goal in cases of where that's an option.
Yeah, and I think what you mean really is if I were to take like this location field, if this is what you're thinking of, and I'm going to add it now to my first map. And it's different than address, so it's not going to collide or anything like that. So we're just going to add it there. Now I've got it. And so now I can come back to my for each statement. And I'm just going to change all of this basically back to what it was. So we're now going to step through local.things again. And now I'm going to, instead of pointing to the address, I'm going to point to the location, because that's what we added in the field. Step through that. Yeah, so here we get the same output, right? Address equals, and then I've got the same explanation because it pulled it out of a flat map in this case. And my resource code is far easier to look at. Is that right?
Yeah, it's a lot easier to understand, though you may not be able to change your inputs as much.
Right, yeah. Yeah, but when you can, it certainly makes things a lot easier for others to come along. Hey, thanks for working through this with me today, Jason. For all of you, like and subscribe to get more content like this, and join us on Discord to be a part of our Learning Terraform community. If you would like to learn more about anything we mentioned here, let us know in the comments and we'll address it.